Hello and welcome to the NavAbility tutorials. This is the welcome for tutorial 3 on insufficient data, where we're going to look at a specific example of range-only navigation. If you haven't seen before, there is a separate getting started video. It's linked below, so go check that out. We at NavAbility are always interested to hear how we can help. We'd love to get in touch and discuss. You can find us at our website, navability.io, or email us at info@, and then we have a Slack channel. It's linked below, or on our repositories or on the website, and you can find us there and get in touch. This application, or this tutorial, has a lot of implications for navigation relating to range-only or insufficient data in general. Range-only examples are the most prominent to show, and so we'll follow that story here. So specific applications could be indoor ranging navigation. So if you've got a constellation of beacons set up in a warehouse or in a manufacturing setting, and there's frequent occlusions to the signal path, or there's accidental jamming of signals to a robot, a mobile vehicle, or personnel tracking inside a building. Similarly, outdoor, if it's a localization, personal localization on a safety application, where loss of signal is possible, due to long range or accidental jamming, etc. So if you have any degenerate cases where you maybe want to localize from 2 or 1 or too few range measurements at a time. This extends to GPS denied navigation, which is a broader category of insufficient data, maybe specifically ranges to the satellites themselves. That's a similar case. Or just missing data in general, where you have too few measurements given the amount of variables you're looking for. Similar underwater navigation, if you have LBL or SBL, short to long baseline acoustic localization, and you have through the thermoclines or the celluclines in underwater applications, bad signal propagation, and you've got situations where ranges are lost or signals are lost. Those are very applicable. There are many cases where you have a transfer navigation problem. In construction, this happens where you're surveying outdoors with GPS, and then your system has to hand over the coordinate system indoor under a roof or in the construction site. So that transfer from one constellation of ranging measurements to a secondary set or an alternative set of ranging measurements, that handover might have insufficient data situations, and this technique is very applicable there. And then you can stretch it, so back to GPS, signal verification. So if you're concerned about spoofing of signals, you might want to do leave one out style verifications, where you want to resolve by removing one or two or multiple signals from your navigation solution and check whether you have consistency. And there are so many more. So again, these are the range-only specific applications, but any solution where you've got too few data, you've got weak observability of your situation, is very applicable, and this tutorial will show you a little bit more. So this tutorial is built around, we simulate range only. So imagine you've got something like a Wi-Fi router or a radio or acoustic beacon, and you can get a range measurement from it. And then you've got some kind of vehicle, maybe it's a cell phone, maybe it's an underwater robot, maybe it's a ground robot, and you're going to find a navigation solution by ranging. That's how this example will walk through. Just diving in a little bit, just to show you what some of the examples will look like. So early on, there's a lot of uncertainty. So on the left here, for example, this is the survey result of a beacon. You're trying to navigate or survey a beacon that you don't know. This is the posterior result. So the belief of where that beacon might be potentially is this entire non-Gaussian result. Or at the same time, the vehicle is being localized. So this shows 3 poses, red, green, blue, and there are 2 hypotheses. So maybe the vehicle is traveling to the right here, or maybe the vehicle started at red here, green, blue to the bottom left. So 2 hypotheses are tracked simultaneously. And in this example, you'll see many more hypotheses tracked. It goes much further and bigger. All right, just quickly, how can you run this? There are 2 ways. A zero install path by going to app.navability.io. I'll click on that in a moment. Or you can get this code online and install it locally from GitHub. I'll show that too. So let me just click on the first one, app.navability.io. This is the app. There's in the burger menu, you'll find the tutorials page over here. Insufficient data is this third one. NavAbility here, and you can choose your own adventure. So maybe you say Python 0 install. You can do static renders as well if you want. Let's go to 0 install path, and if you click here, that will spin up an environment in which you can run that. So the alternative is to get the code raw from GitHub. So if I click over there, github.com, NavAbility, bind the notebooks. There are multiple languages in how you can run this example. So let's maybe say now you want to do Julia, Caesar API, the range only example. Here it is. This is the same content, and you're welcome to download and try it from there. All right, there's a separate video link below that actually walks through this example, as well as the other tutorials we invite you to have a look. Thanks.